Hey everyone, thanks for joining us for our last session of our RAG Deep Dive series. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenters for today. Thanks so much for joining us.
Hello, everyone. Welcome to RAG Deep Dive for our very final session about extending RAG with tools. I'm Pamela Fox. I'm a Python Cloud Advocate, and I am joined today by...
Hey, it's Anthony Shaw, and yeah, I work with Pamela at Microsoft. We're both Python Cloud Advocates, and we work on different things, but we're going to talk about functions, cool tools, agents, whatever they're called at the moment. And we're going to link it all together with RAG, so it's going to be fun.
Exactly. So this is our RAG Deep Dive series. This is the last session in it. So if you missed any of our previous series, you can go back and watch them. They are all recorded on YouTube. We also have slides available for all of them so that you can continue learning from what we covered in this series. Now, this series uses our most popular open source RAG solution as the focus so that we can explore all these different features of RAG. But the things we're talking about are also things that you can use in your own RAG code bases. So we hope that this series is useful for you if you're using our RAG repository here, but also for those of you who are developing your own RAG solutions. So for those of you that are new to this RAG repo, you can get the code from this URL here, aka.ms/RAGChat. And you can even check out a live demo that just has the basic features enabled at this URL here, aka.ms/RAGChat/demo. And that'll just show you the basic features. There are tons of optional features, and that's what we've spent a lot of our sessions on, about talking about different ways of processing multimedia, how to have user login and data access control, how to have speech input, real-time voice, many different ways that you can build onto this RAG. But at the core, this RAG solution uses Azure OpenAI with Azure AI Search, and that gets deployed to container apps or app service. Let me just open up the demo for those of you who haven't seen it. So we can ask a question, and this question goes and searches an AI search index and streams back an answer. And then that answer has citations, so we can look at the documents that the answer was based off of. And people use this RAG solution for all kinds of data, for their company data, for product data, for government data, right? All sorts of documents you can make more accessible using RAG. All right. So today we are going to be extending that RAG, and we're going to be showing different ways that developers have wanted to extend the RAG. So what we're showing today actually isn't in the repo, but are like branches or pull requests that build on top of the repo. Because, we have this generic repo solution that people can use for all sorts of things, but people have lots of different needs. So we want to show multiple ways that you might think about extending that RAG, depending on what your use cases are and what sort of scenarios you need for your RAG. And for all of those, we're going to be using either function calling or this new agents SDK. So today we'll start off with talking about function calling and tools, showing how we're using that in the existing RAG repo, and then showing how we could build on that in our own forks in order to bring in different data sources or have different functionality in our RAG app. And then finally, Anthony's going to show us very exciting, which is how we could ground answers in Bing search results. And he's going to be using the Agents SDK for doing that. And this Agent SDK is very new. So you should definitely learn something from that. Okay, so let's start off with function calling and tools. So function calling is an actual feature of models. It is a very confusing term. because function calling is something we do all the time in programming languages, right? Anthony and I don't think it's maybe the best term, because we always do function calling, right? Like you call a function in Python and that's function calling. But function calling is also a feature, a like supported capability of many large language models. And those language models have actually been basically trained to be able to do function calling. And the idea with function calling is we tell a model like, hey, here's a function you could call. Here's like its function signature, like the parameters it takes. Now, based off this user message, what would the function call look like, right? So we're forcing the LLM to pretend that it's calling a function. So let's look at an example of this. And so this example is from one of my repos that just has a bunch of basic examples. So Python API demos. So you can check out the example here, function calling.py. And in this case, I'm using it with GitHub models, but you could use it with Azure OpenAI. You could use it with Ollama. You could use it with OpenAI.com. You have to use it with a model that supports function calling. So with GitHub models, I'm using, I think, GPT-4o, because GPT-4o does support function calling. I wouldn't be able to use this with like a Phi 3, for example, because those ones don't support function calling yet. So that's the first thing, is make sure you're using it with a model that supports it. And then what we do is actually define the function. So this is this syntax called JSON schema, which is a way of defining a function. So we say, okay, here's our function. It's called lookup weather. Let me make this even bigger. So our function is called lookup weather, and here's the description. You can think of this as like the doc string. And some people like to actually, write their functions like this, right? And actually put this in the doc string, look up the weather. And then, it does some functionality, right? So we're basically describing this function. We're not describing what it does, but we're describing this function. And so sometimes function calls actually corresponds to actual functions in your code. A lot of times they do. In this example, we're just seeing how it works. So this is basically the function that we're describing. It's a function called lookup weather. It takes a city name and it takes a zip code, and both of them are optional. So here we have lookup weather, we have the description, and then we have the arguments that it takes. So it could take a city name and it could take a zip code. And we have descriptions of those as well. These aren't very exciting descriptions, but you can add a lot more to descriptions, and you'll see that our descriptions get a lot longer as we need it. And then we say, okay, we're going to do a chat completion request. This is good, the model. Let me go, and I'll just hard code this so we can see with GPT-4o. And then here's the messages. So we say, hey, you're a weather chatbot. And the user says, what's the weather like in Berkeley? And then we pass in these tools. And so the LLM sees like, okay, here's a user message. Here are the possible functions I could call. And the LLM looks at this user message, looks at the functions, and says, oh, I should probably look up the weather. Let's try this. All right. And so we get the response. It says city name Berkeley. So, and let me go ahead and actually put out the name too, just so we can confirm that it's calling that function. All right, look up weather in Berkeley. What's the weather, or we can say like, is it sunny in 90210? What's that TV show? Always Sunny in Philadelphia. Is it sunny in Philadelphia? Philly. What if we do Philly? And that time, so the cool thing here is that it does a little bit of like spelling correction, right? Anthony, what's your actual city name? It's not Sydney.
I don't really have one.
You don't have one. In that small city near Sydney where Anthony lives.
It's like 10 people here, and I know them all.
It'll probably say Sydney, right? Yeah, it's just going to look up Sydney. But this is the cool thing. We're using, and so an LLM can take these like very unstructured user messages and can suggest very structured responses, right? And function calling is one way we can do that. Another way is structured outputs, which we're not going to be talking about today, but it's definitely one to look into. Now, one thing about function calling is that it does have some issues with reliability, like reliably sticking to the schema. So one thing that's recommended is to use strict mode. And that is, we go like this, strict true, additional properties false. I think this is it, right? Try this. Okay, so that works. So strict mode is something they introduced about 6 months ago, I think. And it is recommended to always use strict mode when possible. There's some situations where strict mode isn't compatible, and you can read about that in the docs. But when possible, you should use strict mode because it's going to be much better at sticking to the schema, because you really want it to stick to the schema. You don't want it to like make up a function name that you didn't describe or make up arguments that you didn't describe. Yeah, so Ahmed says, I don't think strict mode works with all GPT versions. I was just wondering, I was talking about that with Anthony. I don't know if you had a chance to look that up, Anthony, whether it's basically the same versions that support structured outputs. That's what I was assuming, but I don't know.
I think it's a new feature, because this recommendation only came in recently. I think it's with the tool choice mode. I think it came along with that.
Yeah, I think the question is, do you need a minimum API version and do you need a minimum model version? And I actually don't know offhand. But Anthony just mentioned tool choice mode. So that's another thing we should talk about. We have this other option, like parameter, that we can add in here called tool choice. And by default, it's auto, which means it could call 0 functions. It could call 1 function. It could even call multiple functions. And that's called also parallel tool calling. So auto is the default, and that's usually what I go with. But you can also say required, which means it has to call at least 1 function. You could also specify a specific function name if you want to make sure it's calling 1 function and it's that function. I don't know really why you would do that versus just having 1 function and saying required, but it's an option. And then there's none if for some reason you want to make sure it doesn't call any. But in that case, I would just specify no tool. So I haven't had a use case for doing specific function name or none. I'm usually either doing auto or required. And Sadiq asked, how does the model know how to invoke the function and where the function is defined? That's a good question. The model does not invoke, doesn't actually call the function. The model only says what it thinks the function name is and what it thinks the arguments are. So then what you can do is like actually call the function, right? And you could do that various ways. Like you could do like, if you had multiple functions, you could do an if and say like, okay, if, if right here. Okay, so we get the function name, we get the arguments. If the function name is lookup weather, then you're going to call lookup weather with the arguments. I think actually arguments is a string. So you'd actually have to add json.load s from the string. And let me just import JSON. Okay, and let me put something here so you can see print. Okay. City name was okay. All right. Let's try that out. Okay, for Picton. Okay, now it thinks you live in Picton, by the way. Right before it was Wollongong. I remember Wollongong.
Both far away.
We're gonna keep trying. So this is one way you could do it. Yeah, is that you could, go through the tool calls that it suggests and then match the function name to the function names that you have defined, load in the arguments, and call them. If you know it's always going to be their function name, then you could just always call that. But basically the point is that you need to call that function. Now, here we're just using the OpenAI SDK. If you use some higher level SDK, like you use like AutoGen or Pydantic AI or Semantic Kernel, that have more of like an agent-based approach, a lot of times they're going to call functions for you. And they're basically doing this, right? This is what they're doing behind the scenes. So I think it's helpful to see this, just to start to understand how these agent frameworks work, the ones that, take tools. Because the LLM is not actually calling the function. The LLM is just saying, hey, here's the name and here's the arguments that I think you should call. And yeah, and this is the basis of agents as well. So I think this is a really good fundamental thing to understand. Okay, so that was function calling. Now we could also have multiple functions that we could call, right? And we can also call these tools. So you can see like I have tools and each of them is a function. So I think tools might make more sense. And that's also what we tend to talk about when we talk about agents. We say, okay, what tools do the agents have in order to like learn more about their environment, in order to do something to their environment, in order to extend their capabilities? Those are the tools they have. And these tools are basically functions. So here I've got two different tools. We've got that lookup weather, and then we also have lookup movies. And so now it can decide which one it's going to call. And remember, once again, that by default, we're doing tool choice equals auto, and I can add that in there to make it explicit. And we can call this one and see how it works. All right, and then what we see is that it thinks it should use lookup movies, and it thinks the city name should be Sydney. Now, if we said, is it sunny in LA? Then we should see that it says lookup weather and city name Los Angeles. So now it could pick. Now, what we could try to do is to get it to suggest both of them. Can I watch movies? I'm trying to remember it quite like, is it rainy enough in Sydney to watch movies, and which ones are on? Let's try this. Now, in this case, I would actually have to loop through and look at each of them and see if we get multiple back. And we did. So this is what you all can call parallel tool calling, which the idea that it actually decides that the best approach would be to call both lookup weather and lookup movies. And once again, you have to decide how to implement this when you're using like a low-level SDK like the OpenAI SDK. So you could call them sequentially. You could use like a async IO task group and call them that way. Would that be the best way, Anthony? Is there any other ways you'd want to call them in parallel?
Yeah, probably a task group. I think, yeah, async is a good option if you do basically spawn both and then wait for them to be completed at the same time. I think it's collect is the function. Yeah.
So there you go. So yeah, but you could also do sequentially, right? But it's more optimal if you can generally do things in parallel if they're not dependent on each other, and in this case they're not, so better to send them both off. Okay, and I saw there was also questions from Johnny, do we need to capture the message ID of the original to send back with function results back to the LLM for their final result? So that's a great question. So in this case, I'm actually not feeding, in this particular example, I wasn't feeding the results back to an LLM in order to, take its next step. There are flows you can use where you're continually calling, like making calls to the same model, and that model is deciding, oh, do I do a tool call right now? Do I have enough information to answer the message? And in that case, you would want to feedback the results. I think I might have a gist that shows that. I don't know if I put it on here. I didn't put it on my gist. But yeah, you could basically do like a while loop that continually calls. And if the call has a function call result, then you call your function and append the results as a message to the message history. And you keep calling that LLM until you finally have finished your flow. You've got the final answer. I can put an example of that in this repo, actually, because I was asked about that a few days ago, too. So I'll add an example for that, too. Okay. All right. So let me keep going since we have more to cover today. But that was a function calling intro. We're also going to be talking about function calling in our upcoming series. So we can put that in the chat, but we are going to have a Python plus AI 6-part series that's going to include one specifically about function calling and structured outputs. So come to that if you've got additional questions about function calling. So now let's talk about how we use function calling in RAG. So first we have a really simple RAG flow if you go to ask. And in this one, we actually don't use function calling. We just get back search results and we send that to the LM. And we can see that in this thought process here. We say, okay, how do we enable access control? We get back results, and then we send that to the LM, and the LM gets an answer. So that's what we call like the very simple RAG flow, right? User question, retrieve results, send those results plus the user question to the LM. Now, most of the times we use our advanced RAG flow, and that's what's used by the chat tab in our solution. And this advanced RAG flow is really helpful, especially for when you have multiple questions in your conversation, right? So an example here, let me actually do it in there. Like imagine I just type what else, right? So this question, what else, would not be a very good search query for AI search, right? We want to turn this user question into a good search query for AI search. So we actually do that using function calling. So we take the full message history. We say, hey, can you suggest a better query? And we do that with function calling. And then we get back a better query. We use that to search AI search. We get back results. And we send those to the LM and get back the answer. So this is what that function call looks like in our RAG code base. This is part of the RAG solution repo that we've shared. So this is the definition, right? So it says you're going to search sources, and the only parameter is a query string, and that's the string that we're going to use to search AI search. So we're just forcing the LM to suggest a great query string. Then we have to parse it out, and we can use similar parsing code to what I was just showing, right? So we go through, we check the tool calls, we look at the function name. If it's search sources, then we load in those arguments, and now we've found the suggested search query. Now, one thing you'll notice is there's a lot of what I call like defensive coding, because traditionally I'm saying like function calling had a tendency to be kind of flaky, and sometimes you would get made up argument names, made up function names. So we kind of everywhere you'll see like we're checking to see like is this actually what we think it's going to be, right? Like if tool type is not equal to function, we're going to continue. Here we're saying arg.get because we're not sure if it's actually going to have search query in it, and just in case it made up something else. Now, as you were saying, we can now use strict mode, and strict mode should hopefully mean that we don't have to have as much defensive coding, but I still like to keep the defensive coding in there, because if you did use this code base with like a smaller model, like let's say you use it with like Llama 3.1 8B, like running locally with a Llama, you would really want to have this defensively coded, because the smaller the model, the more they make stuff up, in my experience, at least with function calling. So I found it really helpful to have all this defensive coding here. Okay, so that's what we actually do, and you can actually see it here. The thought process is, we've got that system message that says this is what you're going to do, and this is what came out of that function call. This was the argument that came from it, and then we use that to search AI search. Now, this doesn't seem like the most exciting use of function calling, right? We're getting a single string result, and we could have done that with just a simple prompt and not had to use function calling. So I often get asked, like, why are we even using function calling here, right? And the reason is because we found we generally got better results from the LLM when we were asking for it as a function argument, because it kind of forces it to really think more structured, because we're saying like, hey, the query has to be exactly the search string and nothing else, right? We don't want any fluff. We don't want anything additional. It's the search string, nothing else. So that's one of the reasons that when we were adding this query writing step, we just generally saw better results. The other big reason is that by having this function calling step already in the repo, it becomes much easier for developers to add to that function calling step to cover more scenarios and to get a lot fancier. So even though we're not using it for anything very fancy in the repo, all of you could build on that and make it cover a lot more scenarios. So that's what I'm going to show here is a few function calling scenarios that come up a lot. So the first one that we'll dig into is searching a GitHub issue tracker. So imagine that you've got a RAG solution and you want it to search for both documentation and issues. And this is actually based off of one that's being used internally by one of like our on-call groups, right? If you've ever been an on-call engineer and your job is to triage customer issues, you probably want to search the docs. You also want to search the issues to see anybody else has found that issue, right? So this was something that they put in their RAG solution to be able to search multiple knowledge bases. So I've actually got this in a branch that I have open right now, so I can just show the code in my VS Code. So here, what I have is I've got multiple function calls, right? I've got the original one that for searching AI search. And for this one, I added to the description. I said like, okay, you're going to use this function for questions like this, right? Because I'm trying to give it guidance as to when it should call one function versus the other. That's something you need to do once you start having multiple functions, is let it know, like try and give it some hints as to when it's going to call one function versus the other, because that's actually one of the hardest aspects of using tools, is getting the LLM to differentiate between what tool it should use when, right? I know Anthony had a lot of struggle with that as well, right?
Mm-hmm. Yeah, definitely. Yeah, something on that point. That's probably one of the biggest challenges with tools and functions is I think you start off with the idea that you can build this bot that can do almost anything and you can just keep adding behaviors and stuff to it. But in practice, you really only get reliable results with like one or two tool definitions. And what people do often is if they want to make a bot that can do 100 things, is they had add another stage that determines the intent before sending it to like a tool, a prompt. So yeah, they kind of add an additional step in there, and that's largely what GitHub Copilot Chat does. It has like an intent stage where it tries to determine which of the paths to go down, then to make another call after that. It doesn't have 150 tool definitions in a single prompt.
Yeah, that's a good point. So that would be another option to add an intent stage, and that's pretty popular. And the other advantage of that is that you could use a different model for the intent stage, because some people I think intent is an easier thing to do maybe than other steps.
Yeah, just more about reliability really, and just whether this is repeatable. Even I think the strict mode is a really helpful feature because it kind of gets rid of some of that unreliability we had before, where it would kind of half call a function but only populate some of the arguments. The other recommendation is that you use enums as much as possible. So when you do the function definition, if you can use enums, the models are much more reliable at giving enum inputs. And then also kind of the description you give for the tool and its purpose, like that is in itself a prompt. So you have to kind of apply the same like prompt engineering tactics to that description. And that's like super, super important. So yeah, they're all kind of things to keep in mind.
Yeah, that's right. Everything here is also prompt engineering. So you'd want to iterate on it and evaluate which ones work the best across many queries. So here, yeah, we've got the description and we try to differentiate. And then we have the next function, which is GitHub search issues. And it says use this function for questions like what are the top errors with deployment? And then the question string to retrieve issues, right? And I started iterating on this based off of like what I was seeing, right? So a lot of times you'll like start with the basic and then you'll like see what it outputs and then you'll start, adding to it and trying to get it to change. You can also provide few shot examples when using function calling, and I do that in another repo. In this case, I try to give examples in line with the function definition. And then I did actually put the strict stuff here. However, strict is not compatible with parallel tool calling, as in it's not compatible with the ability to have it suggest multiple functions to call. So it's basically going to ignore strict when it suggests multiple functions call. Okay, so here's the tool definition. We have the prompt that goes with the tool definition. So in this one, I also tried to tell it when it would do one versus the other, and I describe both the tools that it has. So remember, when you're using tools, you still also have the system prompt that go along with them. We also give it a way out. If it doesn't think it can do a good query for either of them, we give it an option to not call either. So we try and give it lots of options here. All right, so we've got the function definitions, we've got the system prompt. Then we go and pass those in to our chat completion request. We use a temperature of 0. Typically want to have a really low temperature for function calling. It's the best practice. In this case, I'm doing tool choice equals auto, which is the default, but I put it there to be explicit. And then I need to actually parse out the response, right? So this code looks similar to what we were doing, where we're iterating through and checking to see like, okay, if this is the function name, we're going to, call AI search. Otherwise, if this is a function name, we're going to call GitHub issues. And you could actually, at this point, you could call the functions, but in this case, I returned a class in order to indicate what I wanted to be the next step. But you just basically need to differentiate and make sure you store whatever the parameters were that were suggested. Then here, when I get back those results, I check and go through all of the suggested searches. And if it's a GitHub search, I search GitHub. And if it's an AI search, I search AI search. So this is where I've indexed the documentation, which was just a bunch of markdown files that got indexed with our usual process. And this one's actually doing a live GitHub search, right? Another option would have been to actually index the issues with AI search, but then we have to worry about updates and timeliness and all that stuff. So in this case, I'm actually doing a live search of this public GitHub repo in order to grab the issues and, return them in a way that was fairly compatible with my existing documentation format. All right, so let's actually just look at what this looks like to use it. Probably make more sense. All right, so going back to chat. So first we'll just do a question that should be answered in the docs. So here I said, how do you enable user-based access control? So it gives some recommendations. It's referencing 2 bits of the documentation. This is one of our markdown files here. And this is another one here, right? So it got this from the docs. And so this is all just the normal way that our RAG solution works, is that I ingested these documentation pages. They're chunked. So the chunks are associated with page numbers and the chunked content. And it finds those chunks and then sends them to the LM. Now, we have this one here where I said, summarize issues with manage_acls.py. And what you can see here is that the citation is actually linking to an issue. And when I click on that, I actually am rendering the issue. This was a little tricky because GitHub doesn't allow iframing. So I'm actually downloading the GitHub and sending it, via our server. But then you get this funky result here. So this isn't necessarily the best way to display a GitHub issue, but I just wanted to be able to show it really easily in the citation window for now. So you can see it is actually referencing an issue from GitHub. And the supporting content here is the actual issue, which comes through as markdown. And that's what got sent to the LM. So that's cool. So that means in both cases, it was able to do tool calls. And actually, I print out the tool calls, so I should be able to show you the tool calls for both of those. So you can see that recent one was a tool call to GitHub search issues. And the search query was just manage_acls.py, which is perfect. And then the original one was a cool call to Azure AI Search Docs. And the query was enable user-based access control, which is also a great query. So in these cases, this one suggested a single tool call, and this one also suggested a single tool call. Now, let's see it suggest both. Here we go. So summarize the available documentation and reported issues around manage_acls.py. So far I see a doc, and then I see an issue. So that means it did actually call both GitHub and AI search. And we can see that here where it says it made a tool call to AI search and made a tool call to GitHub. So it's pretty cool. So we can actually search multiple knowledge bases. So this is a general approach that you might use in order to, bring in data, different sources of data. You could also use similar approach in order to search multiple AI search indexes. If you had some search indexes around one topic, some search indexes around another topic, you could, easily use a very similar approach in order to figure out which index to call and potentially call multiple indexes if necessary, right? Okay. So let me just see if there's anything we need to cover before going to this. Yeah, so Paolo is asking if we use Promptflow, Semantic Corner, or directly the LLM API to set up a flow to get the user intent, then call any custom functions, and then build the full prompt output. I think that's a good flow. I don't know, Anthony, what do you thought? Because you were talking about user.
I think that's a good flow, especially if you've got more than like 2 tools, and if the tools might overlap with each other as well. I find that in scenarios where the user question kind of could be one or multiple tools, especially with search, like a knowledge. I think, and I'll talk about this in a minute, like determining the intent is better to have as like a concrete prompt stage rather than just having the tool definitions figure that out. Because I found that even with the same prompt, running it twice would give me different tool invocations. So yeah, that's kind of where it comes back to testing.
Yeah, and I guess the question is, can you do all this without function calling? And you could do this without function calling, but you'd either want to be using like structured outputs, or you would have to have some way of you'd have to have some way of validating your results adhere to the schema. So it's easier to use with either function calling or structured outputs, right? Because you have a schema and you want to validate the results. But if you have really simple parameters, like if all your functions just take a single string, then you may not need function calling, right?
Yeah, you can technically do it without function calls. And there are some models which do that fairly well, but your performance is going to be a lot less because the models themselves have been fine-tuned for the syntax, similar to like how it does the chat conversations. There's like that hidden tag, and all the models have been fine-tuned around like em start. So they've basically had the same thing, which is why they list function calling as like a feature of the model, because that model has been fine-tuned on the specific syntax that says like, this is the function, this is how you return a result, and they've given it thousands of examples so that the results are structured back. I have tried with models that don't support functions to kind of like in my prompt and in my fuse shot to say what I'm looking for is JSON, which is structured like this. And like it is so unreliable that I wouldn't recommend doing it. Anything beyond like a few basic parameters, it just kind of invents stuff too often. It just causes problems. Yeah, you really need that fine tuning stage in the model, which is what the function spec does.
Yeah, I agree. I think that really helps. All right, so another related use case is that, talking about different scenarios, is that you could use a function call to suggest different filters for AI search. And this could even be part of the current function, right? Is adding additional parameters, right? If you have categories or other fields on your AI search index, or even on your database, if you're doing RAG on a database, you can use an LLM to suggest filters. Like I have another RAG on Postgres, and I use function calling in order to suggest column filters to say like, oh, this column should be less than this, and this column should be greater than that. So generating filters for a search is another really nice use of function calling. And that you could do just by adding additional parameters. And I've got a blog post about that here as well. And now let's switch over to some scenarios that Anthony has worked on.
Cool. Okay. Yeah, the first one is escalate to a real person. This is something I kind of submitted last year, but it's kind of testing out basic function call. But the one I really want to talk about is Bing doing grounding, because it's an interesting problem. So if we go to my screen, So this came through as a request in the repo, and it's something that I've kind of been exploring. Like, how would you implement this feature? And it's a combination of like prompt engineering, tool calling, and also thinking about like the user experience in general. So the question is, we've got this our RAG sample, and our RAG sample is built in a way that you've got an internal knowledge base. And you can ask it specific questions in the knowledge base, and it will use AI search to fetch the most relevant results using the similarity algorithm. And then it will give that back to the generate stage and say, here's some results. Can you then structure an answer? So what we wanted to do is extend that behavior so that I can ask it a generic question like what happens in a performance review, and it tells you an answer that's specific to our fictional company and the knowledge base. So like it doesn't answer the question what happens generally in performance reviews, because that's not what the user wants. The user wants what happens in performance reviews at Contoso Electronics. And so it's doing our normal retrieval from the AI search index. And what I wanted to do was extend that behavior so that if I asked it a question which is more specific and not something that's in the knowledge base, like what's the address of Microsoft Sydney, it could find the information online and then give me back the correct information. So it said the address is 1 Denison Street, which is correct, and it even tells me what floor it's on. So how we've basically put this together is using functions and tool calls, but it requires a bit more thought in terms of how the process works, because in both of these questions, if I do an internet search for what happens in a performance review, if I search for that online, I'm going to get results back. If I do what is the address of Microsoft Sydney and I punch that into AI search, it's going to give me matches. So what we've ended up with is a scenario where both the internet search and the private knowledge base search are both going to return results. And then we need to decide which results do we use for the generation stage. Because the last thing you'd want is for the user to ask a question like, what happens in a performance review? And instead of explaining the actual process in the company, it gives you like some random internet page results. So really kind of here is where we need to think about the reputation of the data that we're pulling in and the sources, and how we combine the results together. And this is what makes it an interesting challenge to try and implement. So I would say that I'd love to come on here and say, oh, this is like easy feature you can implement. You just tick the box and off you go, and it just works magically. You need to think through how you want to handle different scenarios. So most of that logic is written into the prompt, which I'll go to in a second. But we can see in the thought process. So let's pick on this thought process. I've basically added an additional grounding search query, which is what happens, which is basically the same thing. And I've done an internet search. That one didn't come back with any decent results online, so I've not included them in our generation stage. But if I pick the second one, which is what's the address of Microsoft Sydney, then the grounding search, which is using the agents SDK, has come back with a source from the internet, and it's given me the result. But when I have that same question and I give it to AI search, it is still matching files in our knowledge base in AI search, because the way that the similarity works, like everything is a match, but the relevance might be quite low. So I've still got back information. And so when I get to the generate stage, I've basically got two sources to sort through. I've got one which is from the internet and one which is from our knowledge base. And we need to decide then which one do we use for generate. And we need to give that information quite specifically to the prompt. So if I show you what that looks like, so in this feature branch, we've got basically a different prompt. Normally in the generate prompt, we have effectively to give the answer, we say, we want you to answer the user's question. Here is a list of like snippets that we found from AI search. Use these snippets to answer the question if you can. Otherwise, say that you can't answer it. So we've essentially had to expand that slightly and say that you're an assistant that helps employees with questions about healthcare or the employee handbook. Answer only with the facts listed in the sources. If there isn't enough information, say you don't know. If the question is not in English, answer in the language used in the question. So this is like our standard prompt we use from the RAG sample. And what I've essentially expanded it to do is to say that we have two types of sources. We've got our sources from AI search, and we've got our web search snippets. And based on the question, I want you to pick whether you use one of the sources or the web search snippets. And I've also said additional web search snippets are included, each with a unique URI and a snippet in HTML. Let me just turn word wrap on so we can see all of that in one place. So if the sources don't answer the question, you can use the web search snippets to find the answer. The original sources take precedence over the web search snippets. So this is really important in the prompt to say that if there's matches both in the AI search one and the web search one, the original sources take precedence over the web search snippets. Now that's specific to our RAG sample, but you actually might want it the other way around if you want. Where I think you get into complications is where they maybe contradict each other. And so that's why I wanted to say explicitly, if AI search is telling you one thing and the internet's telling you another, use the results from AI search. And there's just another thing here about how the results come back. So what I've done is effectively extended chat retrieve read to have an additional tool call, which is like to prepare a query for an internet search. And then I've added an extra class, which is over here, which is a search client. And this search client is calling a new SDK, which is in AI Foundry, which I'll show you in a second. And I take that query and it uses the Bing grounding service, which is a brand new service that we've just launched a few weeks ago to answer the question. So I get back possibly some or no results, and then I give those results back to the agent, and then I inject them back into the prompt here. The other thing I've done is with the tool call, I've done an additional like query rewriting step, so that when I do the internet search, it will rewrite the user question so that it's better for an internet search. Because if the user typed in like a paragraph worth of data, if you just copied that paragraph and put it into Bing, for example, your search results are going to be terrible because of the way that web searches work. It's more keyword focused rather than like the actual semantic meaning. So I've done basically a query rewrite stage, and I've given it some specific examples. And also said, if you can't generate anything, just return the number 0. So we just basically break out of that loop if we think we can't answer it. So the other thing I want to show you is how I kind of put this together. So what I needed was using the new agents playground, which is a feature in AI Foundry. So I set up a AI Foundry hub and a project. I then connect it to the Azure OpenAI service that I have. By default, it will use API keys. So I have to go in there and turn that off and enable Entra ID and then configure the Entra ID. So now my AI Foundry project is talking to Azure OpenAI using managed identity, which is what you want. And then once you've got that set up in the project, you can go to the agents environment and create a new agent. And the ones we have available at the moment are that each agent can basically have multiple capabilities. And the one that I created before has its knowledge capability, which is Bing grounding. So you add files, AI search, or Bing grounding. AI search, I haven't tested this yet, and I don't know how this would work in our sample flow. but you can actually add AI search as capability. So I think where we might end up with this sample is that the agent has both AI search and grounding, but I haven't explored that yet. Like I said, this came out like a few weeks ago, so I'm still learning some of these capabilities. But what I've done with this agent is added Bing grounding, and then I've got the Bing configuration in here. So it is basically this agent knows that it can ask Bing if we need to, and then we can sort of experiment with that. So if you go to Playgrounds and then try the agent's playground, then once I've configured the agent I had set up, which is this one, then I can ask it questions like, the agent would then decide to use Bing for the search, and it would give me back an answer. Now, the other consideration here is, and this is something I'm going to follow up on and add some notes in the pull request, is that mostly with internet searches, you want to be quite specific about which market to search in. And normally, if you've used Bing or another search engine, you specify like the region or the market. So if I said like, where is my local Microsoft Office? It's the answer is not going to be correct, because it's going to probably give me one nearest to the data center. Oh, that's a useful answer. It's actually told me, go and look yourself. When I tried that yesterday, it told me it was in Virginia, because that's close to US East 2, which is where the data center is. So something you need to kind of keep in mind with the search grounding is that you want to have both the language arguments and the market arguments to specify like what region you want to search in, because if the answer is different in different countries or different geographies, then you want to make sure that you include that information in the search. So really kind of what we're doing here is using function tool calling to add an additional step, but we still need to converge the results, and that's what we do in the generate prompt. So the generate prompt is kind of handling the logic really in the LLM of deciding which sources to use. And like with everything, you really need to kind of design some evaluation criteria and then test different scenarios with that one. So we've kind of been playing with different types of questions, harder questions, easier questions in different languages, and seeing like how it handles each of those.
So we have a good question from Greg, which is, trying to figure out which results to use, right? And he was saying, like, could you have another tool that would decide if the internet snippets are more relevant? Which I was saying, like, sounds like the semantic ranker from AI search. So I feel like you could have another LLM call that would do that, where you could pass in all the results and have it maybe like re-rank or drop things, but then that would be helpful.
So something we're not doing in this demo is what was it? In the developer settings, you can set the minimum re-ranker score. We're not using that in this case. What you possibly could do here is you could set you could introduce a score in the internet results, and then you could specify the minimum re-ranker score. And I think then the LLM would probably have a clearer view of which ones to use. But it kind of comes back to how would you tell it what is relevant? Because it depends on the question and it depends on the results you're getting back. Also, how many internet search results you want to include is important. So in this case, I'm only doing one. So if it gives back one internet search result, that's like a good match. So that's another thing to consider. Whereas with the AI search query, we're doing 3. So we're doing 3 results from AI search. So I think if you upped the minimum re-ranker score, then you could kind of filter out some of the results on that side. Another consideration as well is that this new Bing grounding feature is quite clever, because one of the problems I had before this service existed, and I was just trying to write this as a tool, is that if you do an internet search, you get back a list of URLs, and you either then have to go to that URL and like read the page and parse it, and you get into the problem of like, okay, which parts of the page were the relevant ones that gave me the match, or you go on the snippet. So most search APIs give you back a snippet in the results. Bing is the same. So if you ask it something that looks like a question, it'll give you back a snippet that includes part of the paragraph which answers the question, and you use the snippets then when you give it back to the generate stage. The problem is that the snippets don't always actually include all the information needed to answer the question, or you need more context. So I think internet searches in general are actually quite tricky as a feature to implement, unless it's like a really specific question like this one. This is an easy question, or like, what's the office for Sydney? It's like a really easy question. But I think when you start to play around with this a bit more and ask it like a paragraph, or you ask it that requires like 2 bits of information which are in separate parts of the page, that's where you need to think about how you'd fetch that information and give it to the LLM.
All right. And we also had a question from Paulo is, can you please list the steps for configuring AI Hub project, etc., to correctly use the agent service? I don't know if you put the bicep in the repo. We do have some repos that do bicep for it, but I'm not sure if they'll work with this.
Yeah, not yet. So the PR I've got open is basically introducing the Bing grounding tool. It introduces AI project client, and this is a new SDK. So that's the AI project client is the one that requires you to have configured a hub and a client ahead of time, and also provisioned the Bing grounding resource. So to finish this feature, I need to add the automation for it. And like I mentioned as well, you want to have managed identity between the AI project and the OpenAI service. Bing grounding does not yet support managed identity, so you need to use API keys for that in the meantime.
All right, yeah, and I'll link to one of the repos that does set up AI project infrastructure. So I don't know if it's what got everything we need for the Bing grounding. The Bing grounding is very, very new. Anthony figured this out in the last week, right?
Yeah. Well, I made one implementation, and then I had to make another one.
Yeah. Okay, great. So we just have 2 minutes left. So let's go back to talk about next steps. So thank you, Anthony, for that demonstration and for figuring out how to use web search. That's been a big request in our repo and in these streams. So we wanted to make sure that we were able to cover that at some point in this series. So this is now the end of the series. Sad face. But that means that you can now go and watch all of the sessions that happened in the YouTube playlist. And I'll also do a blog post that links to all the sessions plus all the slides, since all of those are available. So please rewatch them. Feel free to use the slides for whatever, if you want to, share them with colleagues. However it helps you, please continue posting questions in our issue tracker or discussions, any questions you have about the repo itself. I will continue to have office hours on Thursdays in Discord. I'll just keep them going. So if you do have more follow-up questions, come to those office hours in the Discord, and that'll be Thursdays. And as I mentioned, we're having this Python plus AI series coming up in March. And what's really cool is that that's also going to be available in Spanish, thanks to our colleague Gwen, who's going to be doing it all in Spanish, porting all the examples to Spanish, hopefully the prompts. So it'll be really interesting to see how how things work in non-English languages. So definitely register for that series if you want to get another introduction to the whole world of Python Gen AI. And also just forward it to your colleagues who are new to this and want to learn everything. And there we go. All right. And we even have also this resource here that has more RAG resources for digging deeper into RAG. Okay. So thank you again for coming. And I know we never get to cover every single question, but come to the office hours and ask them if you've got more questions, or tweeted us or LinkedIn at us or whatever, and we'll see you.
Thank you, everyone, for joining. Thanks to our speakers. We're always looking to improve our sessions and your experience. If you have any feedback for us, we'd love to hear what you have to say. You can find our survey code on the screen or in the chat. Today, our event code is 24790, and we will see you at the next one.